Let's see this way. We close this. Stop sharing. So let's about the things that I mentioned already. I want to go over again a little bit, you know, in a little bit detail. Okay. So as I mentioned, you know, the geoenvironmental engineering is a new field. So we're going to talk about what it is. Again, I want to mention that it's not geotechnical. It's a combination of geotechnical and environmental engineering. So the geotechnical engineering, you know, people don't deal with contamination in the soils and other things, and whereas you know, environmental engineers, you know, they deal with water and wastewater. They're not concerned about soil things. So it's this field of soil, you know, contamination, groundwater contamination, and like a waste containment, you know, that deals with a lot of soil liners and other things. So that's where, you know, this geoenvironmental engineering comes in. So what are the geoenvironmental problems, need for geoenvironmental engineering, emergence of geoenvironmental engineering? So I just mentioned this very, very quickly. So as I mentioned, geotechnical engineering in general deals with these things, okay? Investigation of subsurface conditions, going to the site and drilling and collecting the soil samples, doing, you know, characterization tests, you know, particle size distribution or compaction or consolidation or shear strength. So, and then we use that data depending upon the project for foundation recommendations, roads, buildings, machines, storage tanks, offshore structures, right? And then we also use that soils data or rock data, groundwater data to design earthworks for dams, levees, roads, tunnels, and underground structures. And we also, you know, investigate the land mass problems such as landslides, slope stability, and subsidence. So this is what traditional geotechnical engineering field encompasses. These are all like, you know, interesting things. And these are all, you know, very important for building the infrastructure, right? But then, you know, with the population growth, you know, with not much awareness with the environmental problems, you know, people started to, you know, dump the stuff indiscriminately and then, you know, started having environmental issues. So in 1976, you know, the US Congress has passed a new law. It's called Resource Conservation and Recovery Act. It's called RCRA, you know, or RCRA, R-C-R-A. It's called, pronounced as a RCRA. And there were some other amendments, you know, following years to correct some issues. But this law was passed mainly to control disposal of the waste, you know. So the old waste, whatever way is disposed, that's fine, okay. But the problem here is, you know, that the newly generated waste. I mean, we are generating the waste, right? The waste generation hasn't stopped, right? So so how do we handle that waste? You know, if you don't handle the waste, you know, then we're going to create more problems. So, and that's when, you know, the need for engineered containment facilities came into existence. Okay, so this law, you know, required to have, you know, engineered containment facilities. In 1980, the U.S. Congress passed another major law that's known as Comprehensive Environmental Response, Compensation, and Liability Act, called CERCLA, and it's popularly known as Superfund law. Okay. So to clean up contaminated sites, right, existing contaminated sites where responsible polluting parties could not be identified or were incapable of paying for the cleanup. So you have contaminated sites and you know, it's causing a lot of problems that needs to be cleaned up, but you know, the polluting parties, you know, are not able to be identified, or they are not able to, you know, undertake the cleanup. So this required way to clean up the contaminated sites. So the first law required waste containment systems to be developed, and the second law required, you know, contaminated sites to be cleaned up. So guess who can do better job on these two types of projects? The geotechnical engineers have good knowledge about earth materials, right? Soils, rocks, and they also have a very good idea about the groundwater because they do these, subsurface investigations for all kinds of infrastructure projects, right? And because of their background, they became, a vital part of these projects that dealing with these environmental issues, investigation, design, and cleanup of contaminated sites, as well as design of containment facilities. So this is how, because the geotechnical engineers have this subsurface background information, ideally, those are the people who would be able to do this, these kind of projects, containment facilities and contaminants. So that's how the geotechnical engineers started to get involved in environmental issues. So as I mentioned, basically, geoenvironmental engineers deal with, the soils, rocks, groundwater, when, interact with contaminants, right? So the traditional geotechnical engineers, they never worried about contaminants. So when you talk about waste containment systems, contaminated sites, we're talking about contamination coming in contact with these geomaterials. So if we can understand those interactions, the geo and contaminant interactions, then we will be able to develop solutions to contaminated sites problems, hazardous, non-hazardous waste management or waste containment systems, and we can do things differently, for sustainable development, like beneficial use of waste materials and other things. So that's how this field of geoenvironmental engineering originated. Okay, you guys know about the soils and groundwater, but now you understand, how these materials will interact with contaminants, and then use that knowledge to, design these engineered systems. So as I mentioned, unless these things were required to be done, nobody would do it, right? So as I mentioned, we had the environmental laws that RECRA and CERCLA, they required these kind of projects to be undertaken. So the geoenvironmental engineering started blooming, okay? And these laws and regulations, so they keep changing, they're not like fixed, right? So as they're changing, this field is kind of evolving. And then environmental problems are not like, one-time deals, right? So these problems are happening, all the time. Not only in developed countries and in developing countries everywhere, these environmental pollution problems are happening. In fact, they are growing, every year. So, because, the handling of chemical waste generation and chemical waste generation is happening, right? I mean, there's so much of chemicals transport, chemicals usage, the waste generation, improper disposal. So these kind of things are, especially in developed countries, US and Europe, there are like a strict controls on what, to reduce the pollution. Whereas in developing countries, these things are still happening, and these problems are going to persist, a lot in developing countries into the future. So for these reasons, the geoenvironmental engineers, because of their unique expertise, they can play a major role in terms of developing the pollution control strategies, right? So, so you don't want to have pollution problems. So take care of them before they happen by designing and operating, waste containment systems. And also, if there are contaminated sites, we need to clean up so that, surrounding environment is cleaned up. So that's how this field of geoenvironmental engineering originated. So to talk about geoenvironmental problems, so I mentioned about waste, right? There are all kinds of waste that you deal with, right? So the one waste that is, common, everywhere is the municipal solid waste. So, we'll learn about, the classification of the waste later on, but municipal solid waste refers to all the garbage that we generate in our houses or, in our, institutions, organizations, right? So every day, you whatever you put it in the garbage bin, so you care as long as you put outside your house and somebody picks it up. So you think problem is solved. So that has to be handled somehow, So this waste, goes there, and then if you dispose it, somewhere without proper engineering, so you create these mounds, and then these mounds could, fail, and in a lot of places, this is not in the U.S., but in some other countries. So there are houses right at the toe of these waste dumps, and especially when it rains, you have these slides, and a lot of people getting killed by these things. And then some places you could have these fires, and that could emit a lot of toxic gases. So you have these problems. So this is one of the problems that the geoenvironmental engineers can solve, because the two things to this. Okay, one is how do we fix the problems that are existing, and how do we avoid the problems into the future. Okay, so this is kind of an example of what a geoenvironmental problem is. So we consider the municipal solid waste is less toxic compared to some of the waste that industries generate. For example, hazardous waste, right? All these chemicals. So those are highly toxic, and in the past they used to put it in barrels, and they, in the middle of the night, they used to go and dump it somewhere, wherever they could find, and then over the time they used to leak and cause all kinds of problems, right? And then we are talking about electronic waste. There are so many controls on not disposing the electronic waste, because there are a lot of toxic metals and all these paints and other things. So again, you want to control these hazardous substances entering into the soil or entering into the groundwater, and people getting exposed to these kind of things. So the hazardous waste containment in well-designed hazardous waste landfills is one of the solutions where the geoenvironmental engineers can play a major role. So other type of waste is the nuclear waste. Everybody jumps up and down about nuclear waste being a very clean energy, but because it does not have any carbon emissions. But one of the biggest problems with this nuclear energy is the nuclear waste that you generate. So what do you do with that, right? So here, there's a sophisticated containment systems that you have to develop and contain these wastes, so that the environment is protected and humans are not exposed to these kind of wastes. So this is a very high level geoenvironmental problem that needs very sophisticated geoenvironmental solution. So not only are we dealing with the municipal solid waste, hazardous waste, nuclear waste, there are a lot of mining happens, all over the world. The mine waste is a huge problem. So a lot of mining companies extracting a lot of different resource materials, and in the process they generate a lot of waste. Okay, it could be a solid waste, it could be liquid waste, it could be suspensions like this, and they have a very unengineered storage facilities, and if they fail, or if something is not well designed or operated, if they fail, all this toxic stuff, after you recovered, the stuff that remains, it contains a lot of even other toxic substances. So the failure of those ponds, or just disposal of these kind of materials improperly can create all kinds of problems to the environment and the people around it. Of course, the land is going to be affected, and the land use is going to be affected, and so forth. So how do we contain this mine waste? Can we utilize the waste as some kind of a useful material, or can we contain these wastes by engineered containment systems? Again, that's kind of geoenvironmental problems. So the coal combustion residues, the coal plants, the coal power plants that you see, of course they are bad from because they use fossil fuels, coal that generates a lot of carbon emissions. But irrespective of that, the burning of the coal, you generate this coal ash, right? And in the past, they used to mix with water and pump it into nearby, just unengineered ponds, just the open pits, and then these kind of materials have toxic metals in them, so they basically infiltrate into the ground, and then when it goes into the groundwater, with the groundwater, they could be transported, can get into the rivers, surface water sources. So it's a big problem. So again, this is another geoenvironmental issue where we need to think about can we use this material for some other beneficial purpose, avoid disposal of it, right? And if we have to dispose it because we cannot find any applications right away, then how do we design the impoundments or containment facilities for this kind of materials? So again, that's where the geoenvironmental engineering comes into picture. Okay, so the mine waste, there are all kinds of different mining companies, right? Extracting different resources. But industrial waste, different industries. For example, steel slag, right? So you don't have to go too far from Chicago. If you go to this Indiana, Illinois-Indiana border, you will find a lot of these steel plants, right? So they are creating, steel, and in the process, they create the slag, right? So some slags can be utilized, some slags may not be able to utilize. So you have piles of these materials that needs to be either used or disposed of, right? Carbide lime is another industrial product. This roadway, asphalt waste is another product. Fly ash, as I mentioned, in the coal combustion process, you may get fly ash, or if it gets mixed up with other things, it's called, the coal ash. And these materials, some of them can be used, So, for example, fly ash, some types of fly ash can be used in concrete, but others cannot be used. So, this is other type of slag. So the problem with these materials is that these are not like soils, So they have a different chemical composition and different properties. They have some toxic substances that could be leached. So, there are two things to it. One is, can we use this? Can we understand these materials and use them as a beneficial materials? Or, if we cannot use them, how do we contain them? Because if you don't do those things, you're going to pollute the environment much more than what it is right now. So again, these kind of problems are geoenvironmental problems. So the polluted sites are our past sins. Like if in the past, we didn't have any regulations, and people were disposing, indiscriminately, whatever the way they wanted, and now we are paying for it. There are some sites, huge sites, millions and millions of dollars are being spent to address, the pollution issues. I mean, if you don't do anything, you will have all kinds of, environmental impacts to surrounding public and maybe surrounding environment. And not only humans, we should be worried about environment, the animals, plants, everything, right? So, protection of the humans and the environment in general. Other thing is, climate impacts and extreme hazards. So, whether we are doing the site remediation, cleanup of contaminated sites, or waste containment systems, now we are challenged with, things that we never used to worry about, the climate impacts, right? So we are challenged, to design the waste containment systems in general, but further we are challenged not only design it for safe containment, but also the safe containment should be ensured even under climate impacts. So maybe regarding the cleanup of contaminated sites or waste containment systems. So we don't want them to be compromised. The performance should not be compromised because of this climate impacts and extreme hazards. So we are challenged, with the design of these things for the new non-stationary, impacts that we're seeing. So this is in general is a challenge, not only for geoenvironmental problems, but in general, any infrastructure projects. So this we have to keep in mind and address these things as we consider these geoenvironmental problems. So all these geoenvironmental problems need geoenvironmental engineering. For example, okay, I have waste that needs to be disposed. I don't have any uses for it. I need to dispose them. So what we're talking about is using waste containment systems. Okay, so we may be finding an area that is way away from the cities, and the land value is not that significant. So where we could be digging down to a certain depth, and then putting these barrier systems. Okay, so it could be clays and some plastic sheets, called geosynthetics, the combination of these things. So we're going to learn this one later on. So putting some barrier system at the bottom, and then put the waste on the top, and you have also liquid collection system at the bottom. So it does not allow any liquids to escape into the ground, and also does not, you can remove the contaminated liquids from the bottom. So that way, you're not harming the environment, and you're containing the waste. So these are, design of these liner systems and everything is a geoenvironmental engineering. So here we're trying to control the pollution, right? So if we didn't have these liner systems, contamination would have seeped into the ground, and then it would have spread all over. So these are pollution control systems. So surface impoundments is the waste containment system, or landfills is made basically for solid materials. If you have a liquid materials, you use the surface impoundments. And so hard waste lagoons and ponds, again in some areas, this is very critical to ensure that these are designed properly. And so that's for the newly created waste. But if you have waste already in the ground and contaminated, contamination is already happened, and now we want to control it. We don't want it to spread. So we can build these vertical barriers around the contamination area so that contamination does not spread. So these are vertical barrier systems that we can construct. Let's say you have a dump site, and then things are leaking ground and then moving horizontally. So you can go there and construct these vertical barriers all around the dump site so that nothing escapes from the contaminated sites, in the subsurface. So these are the barriers in the subsurface. And then you can also, if you have on the top, if the waste is exposed, you're going to have a lot of issues, right? So on the top, you can put covers that can, prevent infiltration of whenever it rains, and also any gases that are coming out can be also controlled. So you can put caps on the top of the existing systems. Now, if you have a contaminated site, okay, soil or groundwater, there are technologies that can be used to clean up this contamination. So I'm showing just some pictures here. There are different technologies that can be implemented depending upon, whether, near the shallow, near the surface, the soil is contaminated, or, groundwater is contaminated near the source, or, there's a dilute plume that is in the groundwater. So depending upon, the site specific conditions, and what type of contaminants that we have. So we can use different technologies to clean up the contamination. So and we're going to look at some of these things as we go into future lectures. So the point I'm trying to say is, so these systems have to be designed based on the geoenvironmental considerations. Now, we don't want the problems to be created. We want to avoid the problems. So this pollution prevention and the sustainability are important considerations in geoenvironmental engineering also. So the source reduction is one of the major challenge to industries, to use less materials, create processes that create the less waste. But if waste is generated, can we reuse it or recycle it? So some of these things we need to look at in geoenvironmental engineering significantly. As I was showing you all these different waste materials, not all waste, we don't have to call them waste materials. So they are like byproducts of some processes with completely different composition and properties than typical soils. So knowing those aspects, can we design applications for those materials, So as I mentioned, the climate change that is happening, and change designing to accommodate for climate change impacts, but on a broader sustainability point of view, we need to reduce the greenhouse gases so that the climate impacts won't happen. So there are different carbon sequestration procedures, methods to take out the carbon dioxide from the atmosphere, or there are some techniques where you underground carbon dioxide injection. So you deep underground injection well where you inject the CO2 and then you trap them in the subsurface. So there are a lot of different things that can be done to address the climate mitigation. So, but if meanwhile, this climate mitigation might take some time. So meanwhile, let's say this is an example of, let's say, waste containment or like a landfill that is existing right next to the river or ocean. So that that's going to be affected by sea level rise or surge. So we need to take care of those kind of things, right? So that the waste is not going to be, the containment efficiency is going to be maintained. Otherwise the waste might spread out and have issues. So we can do a lot of different modeling to find out what adaptation strategies, what kind of things that we can do to minimize the impacts of this climate change. So there are two things. One is climate change impacts are going to happen. How do we adapt? Minimize the damage. That's one thing in the short term. But in the long run, we should be addressing removing the CO2 from the atmosphere. So what kind of carbon sequestration and underground storage systems that we can think about. So these are all like geoenvironmental solutions. So as I mentioned, geoenvironmental engineering is kind of a new field. In the beginning, as I was mentioning, environmental engineers were doing their own things. Geotechnical engineers were doing, same thing, their own things. Groundwater engineering or hydraulic engineers were doing their own things, but that intersecting areas were not addressed, with heavy focus. So the problems that I mentioned, geoenvironmental problems, those are the neglected by these environmental engineers, geotechnical engineers, groundwater engineers. So that's addressing those problems became geoenvironmental engineering. In the beginning, it is called environmental geotechniques, but there is a difference between environmental geotechniques and geoenvironmental engineering. I will mention that one in a second. But this is how this geoenvironmental engineering field evolved. So you need to have some background on environmental engineering, some background in geotechnical engineering, some background on groundwater engineering to address geoenvironmental problems. You can understand that, right? Because geotechnical engineers, they deal with only seepage of water, right? Water flow. But if you have contaminants in it, then you have to look at the environmental engineering and contaminant hydrogeology, those kind of things. So then, people said, okay, not intersecting knowledge, but you need to really have a holistic view of geotechnical engineering, environmental engineering, groundwater engineering. So, geoenvironmental engineering is like a broad field where, you need to have understanding of, not everything relevant, information from geotechnical engineering, environmental engineering, groundwater engineering is needed. But if you look at it, a lot of these geoenvironmental problems are really very broad, okay? So if you are talking about contamination, right, we really need to do the environmental characterization of that contamination. What are you dealing with? If I'm dealing with a waste for disposal, you need to characterize that one. If I'm looking at a contaminated soil or groundwater, you need to do, what is the problem? Characterization of the problem, right? So that's important. And then you have to assess the risk of the contamination, right? So, and then you can have, once you understand these two things, then you can have a containment solutions to the problem. So you can have a containment or remediation, you can look at it. And then you can also look at the, prevention strategies and, the sustainability going into the future, right? I mean, you cannot really keep on having pollution problems and these things. So you really need to address, address situation, not to repeat, same kind of environmental problems going into the future. So, make sure we have, future is sustainable. So this is, our idea of, dealing with the waste and dealing with contaminated sites. For these things, you need to have a background in geotechnical engineering, environmental engineering, environmental geochemistry, contaminant hydrogeology, environmental microbiology. So you see all this, economics, right? Environmental justice, because most of the contaminated sites are in the poor neighborhoods, So if a contaminated site is in a rich neighborhood, the community is very strong in having that, cleaned up. But if it is in a poorer communities, then it's, they are neglected. So economy, you don't want to spend a lot of money to clean up. At the same time, maybe cleaning up will create, new economy and new jobs. That's another problem. Systems engineering, you don't want to look at one thing, in isolation. You need to look at, the whole project as a system and look at it. And environmental laws, these are extremely important to abide by. And these are actually the main drivers for, initiating these kind of projects. So now if you think about geoenvironmental engineering, it's a very broad field, So it encompasses all these different fields. Not that you have to be expert in everything. As long as you can have a little bit of working knowledge in other things, or you could be expert in one thing, but having working knowledge in other things, and having a multidisciplinary team, on these projects can really do, wonderful job in understanding and addressing the geoenvironmental problems. So, I've been working in this field for almost, I would say 25 years. I am still learning, a lot of things to be learned, again, if you want to, work on something, day in and day out, something standard, then this is not your field. But, if you want to have a challenges, I mean, what are the new things, new challenges, exciting things that are happening. So there's no time that you can say that, okay, you know everything, there's always something new to learn because of this multidisciplinary background that you need to address these problems. So this is a broad view of geoenvironmental engineering. So I came up with this chart. There's a paper I wrote, so I want you to have a look at it. So with this one, I want to mention the difference between environmental geotechniques and geoenvironmental engineering. Some people use environmental geotechniques. To me, I mean, environmental geotechniques started earlier on. So the understanding of that is applying geotechnical engineering in addressing geoenvironmental problems. So let's say you have waste landfills. So if you have a liner system, so how do we do the settlement analysis? How do I do the slope stability analysis? How do I do the seepage analysis? These are like traditional geotechnical topics that can be applied, in addressing the waste containment systems. But geoenvironmental engineering is in a kind of a different aspect. Here, what we are trying to do is we are trying to come up with a solution to the geoenvironmental problem, considering all the multidisciplinary knowledge. So geotechnical engineering is part of it, but we need to have environmental engineering, and contaminant hydrogeology, and all those things have to be combined together. So the geoenvironmental engineering is putting all the multidisciplinary expertise to solve the geoenvironmental problem, coming up with a engineering solution to solve the problem. Environmental geotechnics is basically applying the geotechnical engineering as needed in designing the solution to the geoenvironmental problem. So environmental geotechnics is like a narrow in scope, whereas geoenvironmental engineering is very broad in terms of its scope. So I always find people using writing geoenvironmental engineering in different ways. So I try to publicize as much as I can what is the right way to write geoenvironmental engineering. So people write this way, this way, this way, this way. These are all like the wrong ways. So the last one is the right way. So geoenvironmental is a one word without any hyphens or capital letters and other things. So I hope after taking this course you don't make a mistake of writing what geoenvironmental engineering is. So in summary of this introduction to this course, geoenvironmental engineering is started as a geotechnical and environmental engineering, but now it is much more multidisciplinary, and it's all about problems of addressing the problems of contaminated sites and waste management and sustainability. So this field, I'm seeing it. There's a lot of research that's going on, and to come up with more innovative solutions to the geoenvironmental problems. But also the environmental regulations are also changing. So that is even challenging. For example, environmental regulations say that this site should be cleaned up within 2 years, for example. I'm just stipulating that. Sometimes they may say some other longer period of time. So that forces us to think about, okay, what kind of technology I need to develop so that I can achieve the goals within that period of time. So that's how these regulations are challenging, the technical community to come up with, more innovative solutions to the problem. So it's a very exciting field to be working in. And as I said, like I've been working in this field for almost 25 years, and there are many, many interesting things to work on in this field. So what I would, recommend you to do, kind of a reading assignment is to read chapter 1 in the textbook. So you get a better understanding of the evolution of this geoenvironmental engineering field. And I also recommend you to read this book, read this paper, The Evolution of Geoenvironmental Engineering. And you can download a PDF file from my website. You can go to my website and then and search under that title, and then you will be able to find it, and then you can download it and read it. So these are very easy readings. So not a really, highly, you know, uh, uh, highly technical, but very easy to read, and then hopefully you can understand much better way than what I explained about this. So I want to pause here and take any questions that you have. Any questions? Anybody? Okay, so what I'm going to do is, I will let you take 5 minutes break. So now it's a 5 or 10 minutes break. So let's say it's 6:30. So we will come back at 6:40. Okay, 6:40. Let's take 10 minutes break. So I have time to drink some water and get back. Um, so I'm going to leave this one on, and so I'm going to stop recording, and then we'll start recording again when I come back. So take a